Saxon Algebra 1, Lesson 91. That's the drum roll. Today is a very important day in your algebra education. We're beginning our study of what we call uniform motion problems. Now that's a fancy name for a relatively simple idea. We're doing problems about people who are going on trips. This is the equation we're going to use to talk about those trips. Distance equals rate times time. I prefer to call these dirt problems because that will remind you of the formula. John always refers to them as uniform motion problems because there's a very important simplification that we use in these problems. We assume that during these trips that our people are making, they're always traveling at exactly the same speed. Now, that is not very realistic, is it? If you're taking a trip, you're probably not traveling at the exact same speed all the time. And do you guys know Jacob Barlow and his little brother Jeremiah? He and I had a long conversation one day about he and Jeremiah taking a pogo stick trip to the Space Needle from their house in Edmonds. And we imagined the two of them pogoing out to I-5, down the expressway, through Mercer, weaving through traffic, and eventually landing at the Space Needle. And we were saying it's highly unlikely that they would be able to maintain the same speed all that time. I mean, Jeremiah would get tired on the hills. They'd have to stop for traffic jams. They would not move at a constant speed. But that's what we assume in these problems. So it's quite unrealistic, but it's a great help to us in making these problems easier to manage. All right? In the problems that we're working in this lesson, there's a very simple story that's at the bottom of all of them. And this is a picture of what I'm doing. We have a person taking a trip from start to finish and then turning around and going back again. 2 trips of exactly the same length. We call the first trip distance 1 and the second one distance 2. And we say that distance 1 is equal to distance 2. Does that make sense? I call these Lord of the Rings style problems because here is little Frodo marching all the way up to Mount Doom, throwing in the ring, getting his finger bit off, but that's a side story, and then turning around and marching all the way back to the Shire. Okay? Another way that these problems can be presented that's very similar is instead of one person making the trip and then turning around and coming back, it's 2 people making the trip together. And this can also be demonstrated by Lord of the Rings because here's little Frodo taking his trip, but here's Sam marching right alongside him. And again, the distance that they cover is the same. Now, this formula is great, but the problem is that John gives us information about rates and times. So this is not going to be enough of an equation to be useful for us. So what we do is substitute in the fact that rate times time equals distance, and we can create another form of this equation that is super useful, right? Instead of distance, I have rate times time. Instead of distance, I have rate times time. This, rate 1 times time 1 equals R2 T2, which I like to say. This is something we can use to actually solve these problems, and we're going to do that right now. Okay, so this style is our Lord of the Rings style. I hope you've all seen the movie, know the story. That will help you a lot. Okay, we've got 3 different versions of these uniform motion problems, and they all are affiliated with a particular story that you'll be familiar with. I hope. On Tuesday, the express train made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Okay, let's draw a picture. We don't travel by train that much. Express trains skip stops, and go faster. They usually have people on them. When I lived in Chicago, and I lived not in the first set of suburbs, but the second set out, not really suburbs, but the second set of stops, I often took an express train so I could zoom past all the first ones and then stop further out, right? And a freight train just lumbers along. It's usually heavy and it's got more stops to make, so it goes slower. Okay, so we have the distance of the express train and the distance of the freight train, but it's the same, right? But I know John is not going to give me this information. He's going to give me rate and time. So I'm going to say the rate of the express times the time of the express equals the rate of the freight times the time of the freight. I can do all of this just by listening to the story, ignoring all the numbers. I just listen to the story and try to get this pattern clear in my head. And then that leads me, once I get this, then that leads me to this equation, and that leads me to that one. This I know is what I'm going to use. Now, I know I need to find all of these variables in the story, and I'll get at least 3 of them and probably have to solve for the 4th. That's the way these usually work. So now that I have everything set up, I know what variables I'm looking for. Now I go back into the story and look at the numbers and try to fill in my list. On Tuesday, the express train made the trip in 12 hours. Time of express train, 12. I don't have to write the units down. On Wednesday, the freight train made the same trip in 16 hours. Time of the freight train, 16. Find the rate of each train if the rate of the freight train was 15 kilometers per hour less than, so we'll just write it like this, the rate of the express train, okay? Once again, we're writing an inequality before we create a balanced statement. So it says the rate of the freight train was less than the rate of the express train. That means this is smaller, this is greater. The balancing number is 15, and so I subtract from the larger size, right? I always like to make my adjustment here because I have room to write, and I either add or subtract depending on whether this is the smaller or the bigger. This time, this side is larger than this side, so I have to subtract. Now I've made it equal. Okay? So now I have something to fill in for 3 of the 4, and that's enough. That gives me information. And P.S. John wants us to find the rate of each train. We can do it now. All right, so now I set up my buckets. And this part should look familiar to you, right? Because we've been filling in things like this. So, time of the express train is 12, time of the freight train is 16, and then rate of the freight train is RE minus 15. We have nothing here, so we just put the same letter in, right? This is all familiar to you now, right? Once we got to here and filled this in, now we're on familiar ground. So now we're just multiplying. I'm going to distribute here, and I'm going to rewrite this so it looks the way I want it. I like to have numbers before letters. Equals 16 RE minus, what's 15 times 16? 240. Okay. Now, I'm going to live dangerously. I'm going to create some negative numbers. I'm going to subtract 16RE from both sides. I'll get negative 4RE equals, that all cancels, negative 240. Divide both sides by negative 4. Luckily, it's not an inequality, so we don't have to flip anything. This cancels, and we get that the rate of the express train was 60, and I think it's kph. Kilometers per hour, yes. Yay. We're not quite done because we also have to find the rate of the freight train. We know that the rate of the freight train is the rate of the express train minus 15. So I'm going to say the rate of the freight train equals 60 minus 15 equals 45. Yay. Okay, that's how it works, you guys. We have two more that are variations that still fit this pattern. So let's look at how they work. Example 92.2. This is one of my favorite John Saxon problems of all time. The members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. Right now I'm just listening for the story. I'm ignoring the numbers. Mr. Ali gave them a ride back home at 12 miles per hour. Now that stirs up all kinds of questions in my mind. Who is this Mr. Ali? Is he a friend? Is he a neighbor? Is he a counselor at the camp? Is he a stranger? Do the girls know him? Why are they taking a ride from him? I don't know. But I do know that they hiked to Lake Tenkiller and then they got a ride back. So I'm going to say this was the distance that they hiked and this was the distance that they rode. You can make up your own letters, you guys. Whatever seems to make sense to you. Some students I know just do 1 and 2. They don't even think about it. But I like to make it fit the story. So once I understand that this is what the story is telling me, now I can sort out the equations. I know that the basic truth is that the two distances are equal. And I know that because distance equals rate times time, I can change this. The rate of the hike times the time of the hike equals the rate of the ride times the time of the ride. Now I make my list. Oh, this is hike first. I like to keep them in order so it'll be easier to fill in. Put my equal signs in, then I'm ready to go back in the book and look for those numbers in the story. The members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. The rate of the hike was 2. Mr. Ali gave them a ride back home at 12 miles per hour. That's the rate of the ride. Find their hiking time if it was 5 hours longer than their riding time. Okay, so the time of the hiking is longer than the time of the riding. It was 5 hours longer, so I have to add 5 there to make it equal. Okay? How far was it to Lake Tenkiller? That's a tricky question. We'll get to that later. For now, I just want to put my variables into my base equation. Rate is 2. The time of the hike is TR plus 5. And we don't have anything here, so we just put the same variable in. Yay. And you don't have to think about this, you guys. It'll always work out. 2TR plus 10 equals 12. TR. We will subtract 2TR. 10 equals 10TR. Okay. So the time of the ride was 1, and we're measuring everything in hours. Okay. How long did they hike? Time of the hiking is time of the riding plus 5, so that would be 1 plus 5 equals 6 hours. Is this the answer? No. John says, how far was it to Lake Tenkiller? He wants to know the distance. How do we find that? The distance, the answer to that question is right here in our puffy cloud of knowledge. Distance equals rate times time. So we can find it 2 ways. We can multiply the rate and the time of the hiking, or the rate times the time of the riding. Oh, let's put these answers in just so everything's in one place. The time of the ride is 1, the time of the hike is 6, okay? So we can either multiply 2 times 6 or 12 times 1, and you can quickly see that they're the same. But the distance equals the rate times the time, so we can do it by the hiking. It is 2 times 6, or 12 miles. Or we can do it by the riding, which is 12 times 1, also 12 miles. So the distance to Lake Tenkiller is 12 miles. This is a great example of how you need to pay close attention to what the problem is asking and never forget your base equation. It will help you out in so many different situations when you feel like you're stuck. So keep that one close at hand. Okay, now we have one more. We're going to the desert. Oh, look, it's our last page of this book. Have we been using this book all year? No. I've been using this book since lesson 30. It's been quite a long haul. Okay, example 92.3. Durant drove to the oasis in 2 hours, and Madil walked to the oasis in 10 hours. All right, so we've got a guy riding. He drove to the oasis. I hope he took a camel. I can only hope that. Okay, so they're both going from wherever to the oasis. It doesn't tell us specifically they started in the same place, but we just have to assume it's easy. Okay, so this is the distance of Durant, and this is the distance of Madill, M-A-D-I-L-L. Okay, so they're both going to the oasis. They're taking different vehicles, but we know that the distance of Durant equals the distance of Madill. Whoops. Using this, we break this out into rate of Durant times time of Durant equals rate of Madill times time of Madill. This is what we'll use as our base equation, and we list everything that we're looking for down the side before we go back to the problem. The first time we look at the problem, we're just trying to figure out the picture. The second time, once we figure all this other stuff out, which we don't really even need a formula to do. Once we understand the picture, we can just follow logic to get all of this. Now we go back and we look for these variables. Durant drove to the oasis in 2 hours. Time of Durant equals 2. And Madill walked to the oasis in 10 hours. How far is it to the oasis? Okay, that's distance again. If Durant drove 16 miles per hour faster than Madill walked. Okay, so driving is faster than the rate of Madill. Okay, so we need to add to this side, and the number is 16. Now it's back to an equation. Okay? Again, we just have to be so careful with those inequalities. Durant drove 16 miles per hour faster, so we had it that way. Then this guy, 16 is the balancing number. We add it to the lower side, and now we're good. Okay, here's my base equation. I'm going to go down here so I have room for my buckets. Rate of Durant, okay, I'm gonna put this thing in. Times 2. Don't have anything for this, so I'll just leave it the same. And 10. Distribute, and I'll just fix that order. I don't like that. 2rm plus 32, 6 plus 6 is 12, yes, equals 10 rm. Divide, or subtract rather, the 2rm to swim it to its friend. Goodbye. 32 equals 8rm divided by 8. And we get that the rate of Madill was 4 miles per hour. All right. And then we find out, I can write it here. The rate of Madill is 4 miles per hour. Now we know that the rate of Durant had to be 20, right? Because we have to add 16 to it. We put that down here too. Oh, 20, we added 16 here. 16 plus 4 equals 20 miles per hour. But John wants to know, how far is it to the oasis? How far, as a question, means distance. And distance equals rate times time. So once again, we can find the distance of Durant, who was the guy driving, right? I'm hoping it's a camel. That's 20 times 2, right? Rate times time. I'll make it like a little chart. Was 40 miles. Is this in miles? It doesn't say. There's no, oh yeah, it is. It's miles. And then Madill, his rate was, his rate was 4 and his time was 10, also 40 miles. So the distance equals 40 miles no matter who you choose to ask, right? And that's as it should be. We should get the same answer because they're going on the same trip. You guys, these are really fun but pretty challenging problems. I hope that by doing 3 of them and having this great background in the algebra, you can focus on understanding how we know the right way to set this up. Okay? We're going to be learning 2 other types of problems that will have slightly different pictures here, and it will become an increasing challenge for us to keep them all straight. So right now you're remembering this is Lord of the Rings style. This is to Mount Doom and back, Sam and Frodo, or if you prefer to add some conflict, you can say this is Sam and Frodo going, and this is Gollum following them. Oh, he's so much trouble, isn't he? Okay, that's the end of lesson 92. Goodbye.